Hey guys, it's Tiffany from SuperEasyMath.com, and this lesson is brought to you by TeacherTube Studios. Today, I'm going to show you how to find the surface area of a cylinder. Surface area of a cylinder. The formula that I'm using to find the surface area of a cylinder is 2 pi r squared plus 2 pi r h. One thing that I really like about this formula is if you understand some basics to how to find the area of a circle and a rectangle, then this formula is going to make a little bit of sense to you. I'll explain first, and it might help you understand what I mean. If you look at the first half of this formula, you'll see that it is really just the double of finding the area of a circle. That's because a cylinder is made up of 2 circles. There's one circle at the top and there's one circle at the bottom. Then there's also a rectangular portion in the center. I'll get to that portion in a second, but right now let's just talk about the circles. Okay? To find the area of a circle, you use the formula pi r squared. Well, in our formula that we're using to find the surface area of a cylinder, we have 2 pi r squared. Where this first 2 come from? It comes from the fact that there's actually 2 circles in the cylinder. There's a circle at the top and a circle at the bottom. So what we're going to do is find the area of just the first circle, the one on the top, let's say, and that would be pi r squared. And really, we know because it's the nature of a cylinder, the circles are going to be the exact same size. All we have to do is multiply that amount by the 2. That's where this 2 in the front comes from. And that's going to give us the area of both of our circles. The second half of the formula, the 2 pi r h, is really the same thing as finding the area of the rolled up rectangle that's in the middle of the cylinder. So really, if you think about it, if you have a rectangular piece of paper and you literally rolled it up, you'd have a cylinder. That's what's happened here. If you remember, to find the area of a rectangle, you take the length times the width, or you could call it the base times the height. It doesn't matter what you call it. But in this case, we only have the height. So if I'm thinking, I can realize that my length going side to side for my rectangle that's rolled up in the center will actually be the perimeter of this circle. Okay? So if I know the formula to find the perimeter of a circle, then I know I can multiply that formula, the perimeter of a circle formula, times my height. And that would be the exact same thing as my base times my height, or my length times my width, however you want to think of it. Okay? So that's where this comes from. The height is just the height, like base times height from a regular rectangle formula. The area of a rectangle formula. The 2 pi r is the formula to find the perimeter of a circle. So that's my base, or my length of my rectangle. So as you can see, that entire formula, which does look kind of lengthy, is actually understandable when you break it down. And the last thing that I want you to know is your answer should be written in square units. For example, 25 inches squared. Let's move on to our first example so we can calculate the surface area of a cylinder. Example number 1. I have a cylinder that has a radius of 3 and a height of 8. This is all the information that I have. Like always, I like to start off by rewriting my formula. So, my formula is 2 pi r squared plus 2 pi r h. Now, I'm going to plug in all of the information that I know and work out the problem in as simple of steps as I can without making things get all complicated for me. Let's do it. I'm going to start by rewriting my 2. I'm going to also start by rewriting pi. I don't really like to work with pi until the very end. To me, it's just really kind of awkward to work with after you multiply, because whatever your answer is, it's pretty much going to be a really long decimal then. So you're going to have to work with long decimals for the rest of the problem, and that's not really fun. So I like to multiply pi at the very end. Okay, my radius is 3, so I'm going to plug that in here, and my 3 is going to be squared. I'm going to add that to 2 pi, another 3, and my height is 8. Now I'm going to put my 8 in parentheses, and that is because if I were to write that 8 right next to this 3, that's just going to look like 38 to me, and I'm probably going to get my problem wrong because I'm going to think, oh, it's 2 pi 38 as my ending, and no, that's not true. You need to make sure it's clear that you need to multiply that 3 and that 8. Whenever you have two variables touching and there's no sign in between them, that's an understood time to multiply. But when we're writing our numbers, we don't actually let two numbers touch without any type of sign or, a dot or something in between, because it's just going to look like a brand new number, and that's going to totally get you a wrong answer. That is not 38. That's 3 times 8. So now I'm going to rewrite this whole problem, except I'm going to solve the parts that are the easiest for me to solve. So I'm going to write 2 here, rewrite pi. My 3 squared is 9. I'm going to add here 2 pi, and my 3 times my 8 is 24. Now I'm going to multiply my 9 and my 2. The reason I can do that is because all 3 of these numbers, the 2, the pi, and the 9, get multiplied. And if you remember, it doesn't matter what numbers you're dealing with or what order you work with them in. When you're multiplying and everything is being multiplied here, anything can be multiplied first or second. It doesn't matter the order. So I'm going to take 2 and 9, multiply them together, and get 18. And that's pi. Then I'm going to add here. Now I'm going to take my 2 and my 24, and I'm going to multiply those together. And I'm going to get 48. And bring down my pi. Now, I know that I can add my 18 and my 48 because they're sort of like coefficients outside of my pi. A coefficient is a whole number that's in front of a variable. And in this case, this symbol is going to be like a variable for pi. So I know that this is sort of like the same thing as saying 18p plus 48p. And using those rules, combining like terms, I would be able to combine my 18 and my 48. So when I do that, I'm going to get 66 pi. So I'm just going to rewrite that as 66 pi. Now, let me say something. This answer, 66 pi, is actually more accurate than the answer that I'm going to, get in my very last step. Let me explain why that is. When we're dealing with the number pi, we're always using it as an estimation. That's because if you remember, pi goes on forever, and it's kind of like, who's really going to sit here and multiply whatever number times 3.14, 159, all that? Nobody is, okay? So when we multiply by pi, we really are estimating, because pi isn't actually 3.14. It's 3.14, 15, all that stuff, okay? So we're estimating when we multiply pi. 66 times the symbol of pi is actually accurate. Like, that's as close to accurate as you can get, because that is actually telling you what the amount is without actually trying to solve it. And our answer that we're going to get is basically going to be a rounded answer. 66 times pi is not a rounded answer. That's more exact. So if I come to the side of my paper and write 3.14 times 66, I'm going to get 207 and 24/100ths. So you could say that that is your answer, 207 and 24 hundredths. We weren't given any units on this particular problem, but let's just assume that the units were centimeters. Centimeters, that would be squared. That's because no matter what our units are, centimeters, inches, feet, whatever, we always write our units as squared. So it really doesn't matter what your units are. You write them down and you put the exponent of 2 right afterward. Let's move on to example number 2. Example number 2. I'm going to start again by rewriting my formula. 2 pi r squared plus 2 pi r h. I'm going to plug everything in that I know. 2 pi, my radius is 5. I'm going to square that. And I'm going to add that to 2 pi. My radius is 5. And my height is 3. So I'm going to put 3 in parentheses. Now I'm going to go through and rework my 5 squared and multiply my 5 by my 3. So I have 2 pi. 5 squared would be 25 because 5 squared means 5 times 5. Plus 2 pi. 5 times 3 is 15. So now, like before, I'm going to rearrange things so I can multiply the numbers that I do have. For the first part of the formula, I'm going to multiply my 2 and my 25 and get 50. And pi is just going to come down with it. I'm going to add here, that's 2 times my 15, and that's 30. And then pi again. So now, this is just like a problem of combining like terms. So 50 plus 30 is 80. And pi just comes down again. Now I can come to the side of my paper and multiply 3.14 times 80. And I'm going to get 251 and 2/10. So that's my answer, 251 and 2/10. Check out my units, they're inches squared. Let's move on to example number 3. I have a cylinder again, and you may have noticed that the line for my radius has been moving around on each problem. For this example, it's on the right side of the cylinder. It's been on the left side before. That does not matter. The radius means the length from the edge of the circle to the very center point on the circle. That's all you need. It doesn't matter which half of the circle it comes from. So let's start by rewriting our formula. 2 pi r squared plus 2 pi r h. 2 pi, my radius is 7, so that's going to be 7 squared, plus 2 pi, my radius is 7 again, and h, my height is 5. Rewrite solving just what I know. 7 times 7 is 49. Plus 2 pi, 7 times 5 is 35. Now I'm going to multiply my 2 and my 49 and get 98 pi plus 35 times 2 is 70. So this is going to be 70 pi. Now I need to combine like terms here. And now I'm going to get 168 pi. When I multiply 3.14 times 168 off to the side of my paper, I get 527 and 52 hundredths. So that means my answer is 527 and 52 hundredths. My units are meters squared. That was my last example. Let's take a quick recap. To find the surface area of a cylinder, we use the formula 2 pi r squared plus 2 pi r h. The first half of the formula used to calculate the surface area of a cylinder is actually just double the formula for finding the area of a circle. That's because there's a circle at the top and a circle at the bottom of the cylinder. Likewise, the second half of the formula is the formula to find the area of a rectangle. because like I told you at the beginning of this video, the center of the cylinder is really just a rectangle that's rolled up. Okay? Find the area of the circles, then find the area of the cylinder, and then you're adding them all together, and that's how you find the surface area of a cylinder. That's the end of this video. Thanks for watching, and don't forget to like and subscribe.